the Earth, a planet with 70% of its surface covered by water, and yet water is its most important and vulnerable resource. Our planet's fresh water resources are diminishing as the need for pure water increases. The demand for more efficient treatment of wastewater, both municipal and industrial, is steadily increasing. On this basis, Koldnäs, in collaboration with SINTEF, the Foundation for Scientific and Industrial Research at the University of Trondheim, and Professor Halvard Ødegaard undertook the development of the now patented Koldnäs moving bed biofilm process.
It has some of the characteristics we were looking for.
After several years of intensive research, the first full-scale plant was constructed in 1989. The same year, the company Koldnäs Miljöteknologi was established. That plant was delivered to Lardal municipality, and it was also the first plant in Norway with nitrogen removal. Today, the plant continues to operate with the original equipment installed back in 1989, including the biomedia, which proves the high quality and durability of the process. Since that time, we have delivered more than 300 plants to customers all over the world, and the Koldnäs process is now one of the best and most documented effluent treatment processes in the world. In 2002, Koldnäs joined forces with the Swedish company Anux, a company specializing in the biological treatment of wastewater and soil.
Combining the world-leading expertise of the two companies, we can now together provide our customers with even more optimal solutions to difficult wastewater problems.
Koldnäs has achieved international recognition for their process, the latest by being awarded the prestigious Stockholm Industry Water Award. The success of the process depends on many factors, such as compactness.
In Singapore, the land is very small, very scarce. So for the wastewater treatment, we try to develop high-rate, compact process, and we found the Koldnäs serves that purpose very well.
Economy and simple operation.
If we had not discovered this microfilm process, we would probably have ended up with much more expensive and complicated treatment plants.
Operational reliability.
As of today's date, the Koldnäs process has given extremely good, stable results, so we are very satisfied.
Flexibility.
Our objective was to find a treatment process that could even decompose the organic material that was most resistant to decomposition, and at the same time be flexible on a daily and weekly basis, since much of the treatment occurs in batches.
Adaptation to existing solutions.
The reason we chose the Koldnäs media process was it gave us the advantages of combining two proven technologies into one treatment process. The technology of fixed media and the technology of activated sludge. This allowed us to go from a 5.4 million gallon per day treatment facility to an 8 million gallon per day facility without increasing any of our activated sludge basins. In addition to that, it allowed us to save about 20% on construction.
We at Koldnäs have learned that the most difficult task is not solving the problem, but defining it. We must therefore think along untraditional lines, in keeping with nature's own premises. 99% knowledge and 1% plastic is a good description of the patented Koldnäs moving bed biofilm technology. Both the shape, the high degree of protected surface area, and the density of the material used for the biomedium help enable the microorganisms to live well protected in what might be described as 3 rooms and a kitchen, under ideal microbiological conditions. Why is the Koldnäs process so effective? By employing several reactors in series, the living conditions for the microorganisms are optimized in each individual step of the process. Bacteria and higher organisms that are naturally found in wastewater establish themselves in the reactor in which they flourish the best. Thus, specialized biocultures, which perform their tasks without competition from less useful microorganisms, are cultivated in a completely natural way. We monitor the quality of the treatment in accordance with requirements and given input values based, among other things, on local pilot plants, as in Toronto, Canada.
We decided to try the process because it's promising certain advantages which could be important for us. One of them is possible ability of up to 4 times treatment capacity from the same tankage volume, and another ability of the process apparently is to achieve nitrification within the same tankage volume.
We are so sure of our coldness process that we provide binding guarantees of the effluent quality. In this way, we can design and customize very compact, cost-effective, operationally stable plants for, but not limited to, municipalities, the pulp and paper industry, the petrochemical industry, the pharmaceutical industry, the food and beverage industry, aircraft de-icing facilities, fish farming, and cruise ships. Coldness can also provide project management, such as here at the RA2, a large subterranean wastewater treatment plant outside Oslo, Norway. In order to provide local assistance to our customers on everything from design and solutions to operation of the plant, we have chosen different strategies. In our domestic market, in Norway and Sweden, we work directly with the end user and we deliver turnkey systems. On other international markets, we work through local licensees or agents. We transfer knowledge, technology and licensing rights to our local representatives.
Shinko Egg introduced the KMT process from Coldness in 1996. Our customers include a wide variety of manufacturing companies.
In order to ensure the proper flow of expertise, we have chosen to establish technical centers throughout the world. We move our expertise closer to the end user, so that we can offer international users of the coldness moving bed process the best possible follow-up, such as at our own company, Coldness we have in our process. Right from the start, the driving force in our operations has been an extensive research and development program. Now, together with ANOX, we make use of external research institutions and universities throughout the world, in addition to our own facilities.
The Research and Development Center of our group is here in Lund. Here in our modern laboratories, we further develop our technologies such as the MBBR. One example is the new biofilm media, the biofilm chip, which will make the MBBR even more efficient. We also try to shape the biological processes of the future. This is a very interesting development where we think that we will be able to change biological treatment from being a costly operation into becoming a profitable process. And this is by controlling the microorganisms so they start producing valuable substances.
In other words, we are in the process of developing the solutions of the future. We are composed of water. We cry water. We drink water. We bathe in water. We live, work, travel, and conduct trade on water. Water is vital. Thus, the treatment of wastewater ought to be regarded as a natural part of man's activity, for which we all have some responsibility. The coldness process is a global participant in the great cycle that brings water back to nature, on nature's own premises. Coldness is returning water to nature.